video, we want to see whether the distance between x and y equals the square root of absolute value of x minus y to find a metric on R. First, to check if the distance between x and y is a metric, we need to verify that it satisfies the following metric space axioms for all x, y, and z being real numbers. The first one being non-negativity. Well, we want to see if the distance between x and y is greater than or equal to 0, and if the distance x and y is 0 if and only if x is equal to y. We know that the absolute value of x minus y is always going to be greater than or equal to 0, since the absolute value is always non-negative. Then when we take the square root, then it's also non-negative. So that's true. Now, let absolute value, or the square root of absolute value of x minus y equal to 0. And square both sides, then we get the absolute value of x minus y is equal to 0. And it's only true if and only if x is equal to y. So the first axiom is met. Next one, we want to test for symmetry. So we want to show that the distance between x and y is equal to the distance between y and x. And this is true because the absolute value of x minus y is equal to the absolute value of y minus x. Last, we want to look at the triangle inequality. So we want to show that the distance between x and z is less than or equal to the distance between x and y plus distance between y and z. And below I have it written in terms of the square root of the absolute values. So the way we're going to prove this is we're going to let a equal the absolute value of x minus y, b equal y minus z. Sorry, so a is, ignore the absolute value, so a is equal to x minus y, b is y minus z, and then when I add those I get x minus z. So notice that all three pieces are whatever is inside the absolute value. So we want to use the fact that the absolute value of a plus b is less than or equal to the absolute value of a plus absolute value of b by the triangle inequality. So we're going to use that to prove the triangle inequality. So starting off, I can take the triangle inequality and also add 2 times the square root of absolute value of a times absolute value of b, because that last term is non-negative. So basically, that preserves the inequality. And now I can take the square root of both sides, and that's still going to be true, the inequality, since the left and the right side are positive, or rather non-negative. And then I can factor the inside. So the inside factors into square root of absolute value of a plus square root of absolute value of b, quantity squared. The square root and the square are going to cancel, and that leaves us with the absolute value of a square root of absolute value of a plus b less than or equal to square root of absolute value of a plus square root of absolute value of b. And remember, we said a plus b is x minus z, a is x minus y, and b is y minus z. So we substitute it, and then that proves the triangle inequality. So therefore, the distance between x and y equals the square root of absolute value of x minus y does indeed define a metric on R.